All right, Algebra 1, using the distributive property to simplify rational expressions. We're already pretty familiar with the distributive property, right? It's where we have something that's sitting outside a set of parentheses. We multiply it by everything that's inside a set of parentheses is typically how we see it. Sometimes the distributive property is foiling. Have we already learned about FOIL? Okay, great. So first, outer, inner, last. That's just another form of distribution, right? Or using the distributive property. It's somewhat more complex, but it's still the distributive property. I'm still multiplying everything outside one set of parentheses by everything that's inside another set of parentheses. So we're going to talk about using the distributive property to simplify a rational expression. Rational expressions typically are a little bit more algebraic than just numeric. Okay? So a rational expression is an expression with a variable in the denominator. All right? So we're looking at something that is in fractional form, has a denominator. Rational expressions can be treated just like fractions because that's what they look like. As with fractions, the denominator cannot equal 0, right? We understand no matter what our fraction is, if I divide by 0, my calculator is going to freak out and say error, cannot, does not compute, something crazy. We can't divide something by nothing, okay? Therefore, any value of the variable that makes the denominator equal to 0 is not permitted. Whether or not we've come into that situation today or Algebra 2 or Algebra 3, what we would call anything that causes any value of the variable that causes the denominator to equal 0 is what we call an excluded value, meaning that we might be able to plug in any number in the world and get an answer except maybe a specific number that causes that denominator to equal 0. We say it can be all these things except this, right? Because that would cause it to equal 0. Does that make some sense to you? Okay, again, all of this usually makes more sense when we actually start working out a problem. Variables stand for unknown real numbers, right? They're placeholders. So all properties that apply to real numbers are also going to apply to rational expressions. So remember that we're talking about a category of numbers when we say real numbers, right? Real numbers are opposed to imaginary numbers, which you haven't gotten into yet, so you don't have to worry about those. The distributive property can be used to simplify rational expressions. So let's see. When simplifying an expression with negative exponents, the final expression should not have negative exponents. How do we get rid of negative exponents? By moving them, right? We change their location, right? If I have a negative exponent, right, where, let's say I have something like n to the negative second. How can I get that exponent to be positive? Move it down. Move it down. Just, all right, so because I just moved it down, right? Just slide it downward. All right, so what we're saying is that n to the negative second, anything in as a whole number sense is a fraction over what? 1, all right? It may not always look like that because I don't need to. So what Caden is saying is that if I want to get that exponent to be positive, right, I'm going to move that exponent, or sorry, the variable with the exponent down, and now it becomes positive, right? All right, so when simplifying an expression with negative exponents, the final expression should not have negative exponents, even if it's something like this. How do I get that to be positive? Move it up. All right, so I'm going to get b to the 4th. Okay, so we want our final expression to have positive exponents, whether that means moving things up or moving things down. Okay, does that make sense? Great. I love it when things make sense. All right, let's look in here. Okay. All right, so this starts off, looks fairly complicated, right? There's a lot of different things going on here. Do we have this pulled up? Let's see. I'm going to do this real quick. I'm going to go ahead and print this out for myself, and then we're going to open a separate page that we can work these out in detail. Looks complicated, right? Looks like that's going to take like 1,000 steps to solve. And my encouragement to you is to just take things one step at a time. Okay? All right. So we've got that. Everybody can see that on their screens, correct? Okay, so I'm going to go back to this page. I'm going to write this up here. Okay, so we've got a to the negative fifth, so that's a negative exponent, over b to the fifth, that's positive. Okay, we've got a to the negative second, c to the fourth, over c to the negative second, plus b to the fifth, over c to the fourth. Okay. So, order of operations would tell me I have to focus where first? Inside the parentheses, correct? And before I can add, well, I mean, what is this? What am I looking at here on the left? What is that at its most basic sense? It's a fraction. And what about this over here on the right? What is that in its most basic sense? And what do I want to do with these two fractions? What are they asking me to do with them? Add them. All right, so we should, I mean, just looking at it in the most basic sense, I have a fraction plus a fraction. What do I have to do in order to, what do I have to have in order to add fractions? Common denominator. All right, so how could I get that? Okay, we got a to the negative second, c to the fourth, over c to the negative second, plus b to the fifth, c to the fourth. What should my common denominator be? C to the what? C to the fourth. Good. All right. So the one on the right already looks like that, correct? All right. So I need to get this thing over here on the left to be c to the fourth. So I'm looking at what do I have to do to c to the second to get c to the fourth? Okay, so I think maybe instead of, what if we moved this guy up? All right, so let's say that we move that up. That would be a to the negative second, c to the fourth, c to the what? Second. Okay, could I go ahead and simplify that? That's a to the negative second, c to the sixth. And all of that is now over what? Because I moved the c to the negative second up. What's sitting below that? 1. All right, so now I have a to the negative second, c to the sixth, plus b to the fifth over c to the fourth. All right, how do I get a common denominator? There's actually two options here, okay? Either of one is right, okay? Option number one is I can get c to the fourth on the left by multiplying by c to the fourth over c to the fourth, right? Okay, or I could move c to the fourth up over here. That would give me c to the negative fourth up there, but it would be over 1 then, wouldn't it? Which would we rather do? You want to have it over 1? Okay, so you're saying move this up. Okay, that's completely legitimate. Okay, as I begin to rewrite this, I'm getting a to the negative second, c to the sixth, plus b to the fifth, c to the negative fourth. Is that correct? Okay. So that basically replaces everything that I had inside this parentheses up here now, right? Okay. So now I am multiplying all of this. Okay. All of that is over 1, by the way. Okay. And I'm multiplying that by a to the fifth, or sorry, a to the negative fifth over b to the fifth. All right. This is where the distributive property comes in, right? If I'm multiplying two fractions, what does that look like? How do I actually do that? Because that's all that's happening here, is that this is multiplication. I know we see a set of parentheses there, but it's really a to the negative fifth over b to the fifth times a to the negative second, c to the sixth, plus b to the fifth, c to the negative fourth, all over 1. What do I do with the numerators? I multiply. And what do I do with the denominators? Multiply, right? Right, we're familiar with that. The reason I ask that is because whenever I add fractions with common denominators, I add the numerators, but do I add the denominators? No. So there's a difference between multiplication of fractions and addition and subtraction of fractions, correct? All right, so the easy thing to see is, what is my denominator going to be? B to the fifth. All right, B to the fifth. Okay, now I'm distributing. So I'm taking a to the negative fifth times a to the negative second. What is that giving me? All right, so problem is that we have forgotten what happens whenever I multiply, right? This is a to the negative fifth times a to the negative second. We have to remember the difference. There is a big difference between this and this, right? And you have to know the difference between those two things, or you'll continue to make the same mistakes over and over again, right? What do I do in this case? Add them. What do I do in this case? Multiply them. So we have to know the difference, all right? So what's a to the negative fifth times a to the negative second? A to the negative seventh. And because this is c to the sixth, it's not like it becomes a to the negative fifth, c to the sixth. It's just a to the negative seventh, c to the sixth. Does that make sense to us? We could do that. We would have got that right. Okay. Now plus, right? Now I have to distribute the a to the negative fifth to this section, correct? Are there any other a's over there, though? So is there any am I doing anything with any exponents? All right, so tell me, what am I writing here then? A to the negative fifth, b to the fifth, c to the negative fourth, okay? All right, how are we doing? Have I lost you?
It's c to the sixth and c to the negative fourth.
You'll notice that these are separate terms, right? The reason why they're separate is because this set over here doesn't have a b. So I can't combine them. And their exponents are different, so I can't combine them. All right? If you'll remember back where we talked about combining like terms where we had variables with exponents, the only way to do that was if it was the same variable set with the same exponent set whenever I go to combine them. Okay? So I can't take 2x to the third and add 2x to the fifth. Right? Those x values are separate. I can't add those. Okay, it's apples and oranges. So it's not just the fact that it doesn't have a b, it's the fact that this is a to the negative seventh and this is a to the negative fifth. You see the difference? Okay, so let me keep going down here. Now, what we can do, just so that you're aware that this is possible, and in fact, likely in this case, all right, is we can write this as a to the negative seventh, c to the sixth, over b to the fifth, plus a to the negative fifth, b to the fifth, c to the negative fourth, over b to the fifth, right? Because there's a common denominator there. On the right-hand side? Absolutely. His question was, can I cancel out the b to the fifths on the right-hand side? Yes. Okay? Now, the reason we want to do this is because I want to get positive exponents, right? But I can't do that. I can't move things up and down in this format right here because of this plus symbol that's there. Okay, I have to split it because if I have a plus or minus in there, I can't just move things up and down anymore. Okay? So down here, can I move things up and down? Yeah, I want to move them so that I have positive exponents. So can the c stay? So I get c to the sixth over what? A to the seventh, b to the fifth. Very good. All right, let's come over here. We know that the b's cancel out, but what do I want to move down? All right, a to the negative fifth becomes a to the fifth down here, and c to the negative fourth becomes c to the fourth. But I don't have anything left in the numerator, so what goes there? 1. Okay, so if I look at, and you guys should still have this page, the original page in front of you, that's A, correct? Yeah. All right. That looked like a lot of steps, right? But was any of it anything that you haven't already learned? No. Okay. Let's do at least, we need to do at least one more of these, right? At least. Okay? In fact, why don't we do this instead? Instead of doing these problems from here, because we're short on time today, let's do a question from your homework. Okay, let's pull up at least one question from your homework. This is lesson 39. All right, pick one out. You want to do F? Okay. All right, so I'll try to do as much as I have time for. We got z to the x over w to the negative second. We've got z d to the negative second x over w plus 5tz minus 2 w to the negative fourth. All right, so just like what we did in the last question, it's probably easiest to get everything in the set of parentheses to be a fraction over 1. Does that make sense? All right, well 5tz is already a fraction over 1, so I'm going to look at z d to the negative second x, and I'm going to bring up my w and make that w to the negative 1. Does that make sense? Okay, plus 5tz minus 2w to the fourth, right? Does that make sense? Okay, so now we have zx. Could I go ahead and bring my w up? Could I go ahead and bring the w up? All right, so that would become w what? W squared. So now I don't have any fractions at all, right? And I could have done that with the other question too. But now what am I doing? I'm distributing, correct? All right, so let's do this one step at a time. Okay, so we're going to add exponents of like bases, right? So I've got z times z. What's that become? Z squared. I've got x times x, right? X squared, okay? I've got w squared times w to the negative first. What's that? It'd be w because it's 2 minus 1, right? So it'd just be w to the first. But I don't have any d, so what does d sit there as? D to the negative second. Doesn't change. Nothing's moving it up or down. It doesn't become 1. All right, now, next is we distribute over to this set. Okay? There's no coefficient to multiply the 5 by, so does that just stay 5? Yeah, that's just 5. All right? Let's see. There's no t, so does t just stay t? Okay, now the first thing I see is z. So I got z times z. Z times z becomes z squared. And there's no x, so what do I have? I just have the x from what I have on the outside, and there's no w, so I have... Sorry. Okay. Which part do you want to see, Reagan? Do you want me to go back to? Okay. I'm just nervous about what time you guys get out of here. Is what, 9:31? Oh, we got a little bit of time. We should be able to finish at least a couple of these. All right, we're good? Okay, so I'm distributing the z to every other z in the first set, right? So z times z is z squared, right? X times x is x squared. W squared times w to the negative first is just w to the first. And there's no d. I'm not multiplying by any d, so I just keep that the way that it is, okay? And then I come over, and I've got to distribute, so I have to bring it over. And that's where you're seeing the green, right? There's no coefficients to multiply 5 by other than just 1, so it remains 1. I'm not multiplying by any t, so I just bring the t down. So I do multiply the z times the z. That gives me the z squared. But I'm also multiplying by x and w squared, but there's nothing over there, x and w wise, to change any exponents with. So it just becomes x and w squared there. Okay? Am I still going too fast? Okay. So here, we're bringing this over now, and we're distributing to this set. Okay? Do I do anything with the negative 2? No, it just remains negative 2. I'm basically multiplying it by 1. Let's see, z. Am I multiplying? Are there any other z's? No, so it's just what z I'm bringing across. Are there any other x's? No, so I just bring that x across. Are there any other w's? Yes, I've got a w squared and a w to the 4th, so that's going to be w to the 6th. Okay? Now, as I look across here, I could combine any like terms where I had the exact same variables with the exact same exponents. Let's see, I got a z squared here, I got a z squared there. But do I also have an x squared over here? No. So red and green are not like terms. Okay? I've got a z squared here. Do I have a z squared in black? No. So I don't have like terms. So if I'm looking across, right, I'm not saying that we're done yet, but there's no combining of like terms. The final thing I want to do is drop negative exponents below the division bar for each set. So what needs to move down in red? The d. So I'm going to get z squared x squared w over what? D squared. Okay? All right. Over here, does anything actually need to move down? No. So everything can stay there. Okay? In black, does anything need to move down? No. So it just, let's see. Is that everything? I think I just kind of accidentally changed the order there. So z squared x squared w over d squared plus 5tz squared xw squared minus 2z xw to the 6th. Yeah, that's our answer. Okay? We got time for probably another question from your homework. G. Okay, G. All right, let me take a, it says a rectangular canvas is to be painted. The area of the canvas with length and width is represented by this expression. All right, because area is length times width. So you actually don't have to change anything. They actually show you what the expression is. Right? They've already written it out for you. So t squared, yeah, very nice of them. T squared y over z, okay, times t to the negative 3rd over y to the negative 2nd. That's ugly, but I'm not going to change it. Z to the negative 4th over y to the 5th t. Now, what I've told you is that it's easiest to move everything in the numerator position, distribute, and then bring down my negative, and then move my negative exponents down, right? Okay, so let's go ahead and do that with this outside. What would that be with everything in the numerator position? I'm looking at this. I want to move everything in the numerator position. What am I going to write? T squared, y, z to the negative 1. Perfect. Well, I'm going to move everything into the numerator position, so I don't have to write anything as over 1. It'd be somewhat tedious. All right, now I want to do this set as everything in the numerator position. What am I going to write? Y to the 2nd, t to the negative 3rd, because it's not moving anywhere, right? Plus, okay, this set, everything in the numerator position. Z to the negative 4th, because it's staying there. Y to the negative 5th. Okay, now we distribute. Okay, so I'm going to multiply everything here by everything in here. Okay, so I'm going to get t to the what? T to the negative first, right? Because 2 plus negative 3 is negative 1. I'm going to get y to the what? Third. 1 plus 2 is 3. I'm going to get z to the what? Negative first. Good. Okay? Okay. Now we're going to come over here. Plus t to the what? T to the first. Good. T to the first. Because 2 plus negative 1 is 1. I'm going to get y to the what? And y to the negative fourth. Okay, because 1 plus negative 5 is negative 4. I'm going to get z to the negative fifth. Because negative 1 plus negative 4 is negative 5. Okay. All right, now let's go ahead and move things across the division bar as needed. All right, what's going to stay up top? Anything? Y to the third. Okay, what goes down? What do I get in the denominator? T and Z. And I don't have to draw their exponents. Why don't I have to write their exponents? Because they're 1. Okay? Plus, okay? Does anything stay in the numerator position here? T. Okay? What do I get down below? Y to the fourth, Z to the fifth. Let me check your answer here. That's exactly right. Okay. I don't know if doing this by colors helps or not. Kind of. If you can, I'm fine with that. Just know that you may not be able to do that on other tests and things of that nature. So I don't get into like a crutch type of scenario where if I can't see it in color, then I can't do the math. Okay. All right. Based upon evaluate scores, I've scored your evaluates. I haven't gone through and tallied up homework passes yet. So I'm not saying that you don't. I'm just saying that I haven't had time to put that together. All right, so I'm going to hit stop here. Hopefully, I've covered 2 of your probably harder questions. I would say if I'm going to break this into 2 rules, my rule number 1 is get everything in the numerator position. Then distribute, right? I guess there's a third rule. Then move everything to positive exponents. Can we do that? Great. Okay.
Get everything to numerator what?
Okay, rule number 1, okay, is you set this up. Move everything into the numerator position. Okay, rule number 2, okay, distribute. Okay, rule number 3 is get everything into positive exponents. That should essentially get me what I need out of this. Okay? So if you can do those 3 rules in those orders, you should be able to get these right, because that's all we did in these questions. Okay? I think that's going to be the simplest method for you guys to get where you want to be. All right, I'm going to hit stop now.